This is a short video on putting forward some of my thoughts on the cases that Reed is sending that are using Triton. Because when we go into these Triton cases, we have the appearance of these cell-like structures, which originally I thought were mesenchymal stem cells, or white blood cells, or leukocytes. But in looking at this carefully, I no longer think these are stem cells. This is an effect of the Triton and perhaps the irrigation technology used here, which was sweeps. And some of these were single needle irrigation. But these structures are very unusual. So what the question is, what are these cells? And if they're not cells, what are they? Since this has to be an inductive process, what do we actually observe when we look at these cases? First of all, they are structures that are approximately 5 microns in diameter, very uniform in size throughout all of the cases. They appear in layers or sheets, just as cells do, which is why I thought they were originally mesenchymal stem cells. They are only in Triton-treated cases. We don't see these in other traditional irrigation cases. And they appear to be just superficial to the mineralization front or the demineralized front. So to review, there are 5 microns in size, very uniform. All the cases we've looked at, all the same size. They appear in layers or sheets of cells, just as cells do. We find them only in Triton-treated cases. Haven't seen any pictures like this in non-Triton cases. They appear to be located immediately above the mineralization front, laying right on top of the mineralization front, and some of them actually look like they fall into the mineralization front. To understand this better, let's look at traditional irrigation cases where we have a smear layer that overlays the mineralization front, and in traditional cases that smear layer is demineralized and removed by our irrigants. If we go back to the histology and actually consider where we are looking and from what direction, you can see that the odontoblast layer is typically removed during instrumentation or through chemical action, and you're actually looking at the layer of predentin that's been exposed from removal of the smear layer. So your vantage point is really looking at the predentin, which is partially calcified, partially mineralized from the odontoblastic process, and you're looking at this area between the mineralization front, and actually you are into the predentin. So we assume the odontoblast cells are gone or removed or chemically removed. So you're actually standing right there at the mineralization front at the entry to the predentin. And in the predentin, there is crystallization by hydroxyapatite crystals incrementally as that turns into a mineralized tissue. So what do we observe with no instrumentation and no irrigation? Imagine we could take a tooth, section it, split it into sagittal sections, not use any irrigation procedures on it all, but just clean it with water. What would we actually observe? Well, we did this. We took a tooth, we took the pulp out, and we scrubbed it with just water. And what you see is kind of the naked dental wall with much of the predentin removed. And you see a very clean wall. But here you see the mineralized part of the predentin. And in various places in the canal, it looks different. You can see there's there's partial mineralization going on. So as you're standing on this vantage point, you have to be prepared to see partial mineralization. Here you can see a water-only irrigation. You can see the mineralization front, and you can see the collagen substructure of the chalcospheroids in the predentin. So the goal of this is to kind of understand what predentin looks like with the various irrigation solutions that we use. Now here is the same thing was done, but only using sodium hypochlorite, which removes the organic debris but does not demineralize. So here you can see the collagen substructure of the predentin. It's mineralization actually taking place as that mineral fills in the chalcospheroids. Now when we add EDTA to it, now it becomes more difficult because you don't know whether it's being mineralized or demineralized. So you develop your pattern recognition based on really how long the EDTA has been present, how long the bleach has been present, and what these structures look like under various times and concentrations of EDTA. So a lot of this is dependent upon what the mineralization front looks like, what the predentin looks like with these different solutions. Here you can see the partial demineralization, the collagen substructure of the mineralization front. And now you have a sense of what predentin can look like. So now let's take a look at some Triton cases and see how they're different. So here's a Triton case, and you can see demineralizing predentin, and you see those cellular-like structures there. And you can see that this demineralization is not very uniform, and it's different in different places. There you can see the layer-like structure of it. And in areas where it's been present longer, or maybe a laser has been used, then you get even a different sense of what these structures are like, because these structures appear to be part and parcel of the mineralized layer. There you can see a couple of them. So they're actually part of the process of demineralization of the predentin. So this is why I don't think that they're actually cellular structures. They're an effect of the Triton on the predentin that has this effect, and they're actually impregnated into the predentin. So somehow when the predentin is being demineralized, it leaves these structures as an effect of the predentin demineralization. So that's my supposition. I'm trying to reason through this just like everyone else. These structures are very unique, but that's my supposition. I'm open to a different opinion if someone has some other ideas.